Hey there, everybody. This is day 17, I guess. And it looks like it's about to start. So, audience will start seeing my content in a minute. Reservoir research. Day 17, reservoir research.py. And let's go check it out. Let's make sure that I'm actually streaming. You are live. Awesome. You arrive in the year 18. If it weren't for the code you got on 1018, you'd be very cold. The North Pole base hasn't been constructed. Rather, hasn't been constructed yet. That was making a little progress. Not a lot of liquid water, getting very dehydrated. You scan a two-dimensional vertical slice of the ground nearby. Covered is mostly sand with veins of clay. The scan only provides data with a granular square meters, but it should be good enough to determine how much water is trapped there. In the scan, X represents the distance to the right, and Y represents the distance down. There's also a spring of water near the surface at X equals 500, Y equals 0. The scan identifies which square meters are clay, your puzzle input. For instance, suppose your scan shows the following veins of clay. X equals 495, Y 2 to 7, Y equals 7, X equals 495 dot 501, X equals rendering clay as pound, sand is that, water spring as plus. Increasing the right downwards, this becomes 494. The sprig of water will produce water forever. Water can move through sand but is blocked by clay. Water always moves down impossible and spreads to the left and right otherwise, filling space that has clay on both sides and falling out otherwise. For example, if 5 squares of water are created, they will flow downwards until they reach the clay and settle there. Water that has come to rest is shown here as this, while sand through which water has passed but is now dry again is shown as that. 2 squares of water can't occupy the same location. If another 5 squares of water are created, they will settle on the first 5. Water pressure does not apply. If another 4 squares of water are created, they will stay on the right side of the barrier, and no water will reach the left side. At this point, the top reservoir overflows. While water can reach the tiles above the surface of the water, cannot settle there, so the next 5 squares of water settle like this. Notice especially the leftmost pipe. The new squares of water can reach this tile, but cannot stop there. Instead, eventually they all fall to the right and settle in the reservoir below. After 10 more squares of water, the bottom reservoir is also full. Finally, while there is nowhere left for the water to settle, you can reach a few more tiles before overflowing beyond the bottom of the scanned data. How many tiles can be reached by the water? To prevent counting forever, ignore tiles with a y-coordinate smaller than the smallest y-coordinate in your scan data or larger than the largest one. Any x-coordinate is valid. For example, the lowest y-coordinate given is 1 and the highest is 13, causing the water spring in row 0 and the water falling off the bottom render, rows 14 to infinity, to be ignored. So, counting both water, rest, and other sand tiles, the water can hypothetically reach the total number of the tiles is 57. So 15, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 40, 41, 42, 43, 44, 45, 48, 49, 50, 51, 52, 53, 56, 57. Okay, so let me understand how this works. The spring of water will produce water forever. Water can move sand is blocked by clay. Water always moves down if possible and spreads to the left and right otherwise, filling space that has clay on both sides and falling out otherwise. For example, so 5 squares of water are created. They will flow downward until they reach the clay and settle there. Water that has come to rest, while sand through which water has passed but is now dry again, is shown as 2 squares of water can't occupy the same location. If another 5 squares of water are created, they will settle on the first 5, filling the clay reservoir a bit more. Water pressure does not apply. If another 4 squares of water are created, they will stay on the right side of the barrier, and no water will reach the left side. At this point, while water can reach the tiles above the surface, it cannot settle there. So So basically the idea is it goes down and it marks all those. Then once it hits bottom, it goes left and right until it is full. Or always moves down possible. Spreads to the left and right otherwise. Are you kidding me? You're not kidding me. All right. Well, this kind of is not good, but that's fine. Let us see how far we can get, and maybe we won't get very far because this looks like a real pain in the ass. So raw is that. And is it the case there's a spray one in their surface at x equals 500, y equals 0. So water's always at x equals 500, y equals 0. And so so let me do make grid raw, which is a string, and it is going to return a list of actually no, we're going to do as always xy from typing import list named tuple and tuple just in case. I might not use a name tuple here. XY is a tuple int. And so my grid will be a dictionary from XY to strings. And what do I want to do? I want to say for line in raw.split on new lines. And so I'm going to use a regex here. And my regex is going to look like this. Regex equals xy equals and let's make sure that it always looks like that. It always looks like that. And 0 to 9 plus comma xy, and let's capture that again, equals 0 to 9 plus dot 0 to 9 plus. Okay. So let's say first chord, second, low, high equals re.match regex line dot strip dot groups and let's say grid is this, and I might regret having it be a dict. So if first equals x, for y in range int low int high plus 1 grid and so what I want to do, grid say x equals int chord and grid xy equals, and we're representing these as pounds, is that right? Yep. Otherwise, first is y, so y equals int chord for x in range int low int high plus 1 grid xy equals pound and then we know that grid 500 0 grid 500 0 equals the spigots, so I'll just do that, and then I'll say return grid, and grid equals make grid from raw. So let us try this. Day 17 reservoir research, invalid syntax. Doesn't need a colon at the end of it. Let's try it again. Name dict is not defined. Let's import dict. 495.2, 495.3, 495.5, 6, 7, 7, 7, 7, 7. Def show grid, which is a dict. Let's do this. Grid equals dict xy string, and then this can return a grid. And this will be a grid as well. And I'll just have it be a string, and I can print it. And what I can do is I can say x low equals min of x for xy in grid.keys, x high equals max of x for xy in grid.keys, and then I'll do the same thing with y. Okay, and now what I want to do is when I show it, I want so let's say rows equals grid.get ij period for and so now I want x to range. So for I in range x low, x high plus 1, and this for j in range. Actually, let me just do xy, that'll be easier. So y for x, for y in range y low, y high plus 1, and then return new line dot join empty dot join row for row in rows. So let's run this and then show the grid. Print. So this looks like, I think, the grid that they showed us. So at least we've Okay, so we've made our grid, and now the question is, let me remind myself what the problem is asking exactly. How many tiles can be reached by the water? To prevent counting forever, ignore tiles with a y-coordinate smaller than the smallest y-coordinate in your scan data, or larger than the largest one. So what I want to do is go water, 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 and then I'll fill up here, then I'll fill up here, then I'll fill up here, then I will go here, and then I will go spread, 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 spread. And so let's think about an algorithm. So water enters here, and then it goes here, and now nothing below me. So I'm just going to go down again. Nothing below me. Go down again. Nothing below me. I'm going to go down again. I'm going to go down. I'm going to go down. And now I'm going to go to my left and go to my right. Then I'm going to go to my left, go to my right, and so on. And then I'm going to stop, right? And now I'm going to go back and here. And I'll say, I can't go down because there's too much below me. So now I'm going to go left, 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 and right. And now I can't do any more. So I'm going to backtrack and go here, spread, go here, spread, go here, spread, 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 go down, spread, 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 spread. Okay, so I think I understand this. And now the question is, okay, I think I get it, amazingly. And what I'm going to do is I'm just basically just going to have, it's kind of like a depth first search, where I keep going, keep going, keep going, keep going, keep going. I get here, I can't go down, but I can go either left or right. So I will explore as far as I can, and then backtrack. And ignore tiles with a y-coordinate smaller than the smallest y-coordinate in your scan data, or larger than the largest one. Any x-coordinate is valid. So, okay, so I think I get it. So let me call this, let's flow into a grid, which is a grid, and I'm going to return a new, yes. So let me do that again. And it turns out that it seems like above minimum y value, so we don't want that plus in there. So I'm going to take that out. And let me run this again and print show grid. And now this is this thing, okay? And so let me do this. Frontier equals, and it's going to be 500, 0, okay? And so what I want to do is while frontier, and let's say xy equals frontier.pop, okay? So I'm going to pick this up. And what's going to happen is so let me think through this a little bit and think through what I said. So explore from here, 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 explore from here. And now once I explore from here, I want to go out to the side as much as I can, as much as I can, as much as I can. And then I say, can't go anywhere further from here. So I'm just going to say that I'm done. And then I will keep going. And then I'll do a second exploration, which is to say I will add this and add this. So I want to add down, but leave me on the queue, and then go back and I think that will work. And so actually, let me do the following. Port enum. So class dir enum.enum equals, actually, no, I'm not going to do that. I'm just going to say frontier equals 500, 0, and I'm going to say -1, 0, 1, or -1, 1, 0, where the -1, 1, 0 is directions to explore, left, right, down. Okay, and so what DTE equals frontier pop, and so what do I want to do? I want to say if y is bigger than y high, so that means I've fallen off the bottom of the screen. And if I've fallen off the bottom of the screen, I don't want to go anywhere. So I'll say continue. And similarly, if y is bigger than y high or y is less than y low, continue. Okay. And if no directions to explore, then I also want to continue. And then otherwise, next direction equals dte.pop. I want to do frontier.append xy dte, which has remaining directions to explore. And then if next dir equals 0, so that's down. If below equals xy plus 1, and at below equals grid.get below, and if not at below, so if it's empty, then I want to do two things. One is I want to stick water there. So I'll say grid below equals W for water. And I'm not going to distinguish between his lines and his squiggles because I don't think it's important to. And then I want to add that to my frontier as well. Frontier.append x, y plus 1, minus 1, 1, 0. So go down and fully explore it. And so I think that's it. Otherwise, if nextdir equals 1, which is to the right, right equals x plus 1 y, at right equals grid.get right. If not, at right grid right, and this is, I'm repeating the same code. So let me just change this. Neighbor equals x, y plus 1. Elif nextdir equals 1. Neighbor equals x plus 1 y. Elif nextdir equals minus 1. Neighbor equals x minus 1 y. And then let's say if neighbor not in grid, so that means there's not water there and there's not clay there. Grid neighbor equals W. And then frontier.append neighbor 0, neighbor 1, and minus 1, 1, 0. And then I think that's that. And then I'm just destroying the grid basically, so that's fine. So let me try this and flow grid. And that didn't do anything, so that's not good. Print show grid. While frontier, print frontier, print x, y. So the problem is that I need to start this at 1 because that's right below. And let me just do this. Grid, I'll assign the water here, equals W. So every time, so that way I'll do it. So let me try this again. And this might not work. So let's see what grid looks like now. It is going crazy. And why is it going crazy? It's going crazy because because my logic is not right. So what I want to do is I don't want to explore in all directions. I want to explore only in the down direction. Okay, so so I got this very wrong. So and I will do it like this even. I think it'll make my life easier. So I'll say x, y, direction to explore equals frontier.pop. And now if direction to explore, actually no, I think I was righter than I thought. So I don't want to necessarily explore all these guys. I want to explore them only if I can't go down. So let me think about how I do this. I'm here, I go down, I go down, I go down, and do this and go down. And now I can't go down. So once I can't go down, I add on the left to the right, and so on. So now those fill up. So I stop, 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 go back up here, and now I can't go down. So okay, so I don't think I need this direction to explore. So I'm just going to start with this, and let's start again. So the grade xy is water. If that's out of bounds, continue. And so let's think about this. So below equals xy plus 1. Okay, and so if not grid below, then what I want to do is I want to do the following. Frontier dot append xy. So I'll push this guy back on the frontier, and frontier dot append below. So anytime I can explore below, I'll say, okay, stick this guy back is somewhere I might come back to. But now I really want the next place to be below. If not, grid below. And then I'll stick a continue here. Okay. So otherwise, there's something below me. So otherwise, there's something below me. So if there's nothing, so left equals x minus 1y, right equals x plus 1y. And if I do left and right, then I'm probably never going to have to backtrack to here. So let me do this. If not grid left, frontier dot append left. If not grid right, frontier dot append right. And then I think that's all I need to do. So let me try this one now. Key error 5.2. Okay, so that's fine. And same problem. So let me just rewrite this as below in grid, if not left in grid, and if not right in grid. Okay, so let's try this one more time. And it's still running way too long. So let's try this out and see what grid is. And it's still going everywhere. And it's going everywhere because and so what I want to do is I want to print show grid, and then we can see what's going on. So that's let's add an extra print, and let me just add count equals 0, count plus equals 1, if count equals 10, break. So this will just allow us to see only the first 10 steps. So it goes here, water, 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 flows to the left, flows to the left. So that seems to be doing the right thing. Let's do 100 and see what happens. So it seems to be doing so this backtracking logic is not working when it's flowing off the bottom. And so what I want to do is I'm going to use a different name for off the bottom. And that's as follows. So if no, so like we're doing mostly the right thing. The problem is that we're screwing up when we get here. So let's so if you look at what this does, it's going over here, and then it's going over the side, and then it's going over the side, and then it's going here. And now what I need to do is I need to say if I've hit the bottom, then everything above me is basically can I treat it as a wall? So let me think about the right way to do this, because we're very close. But this ending case is making things difficult. So let's think if we can come up with a hack for this or something. Because you see what happens is it gets here and it says, okay, I'm actually off the bottom of the grid. So let me backtrack, and now I'm going to spread to the side when really I shouldn't. So let me not do this here, and let's say grid 501 equals W. So So if there's nothing below me, and y is less than or equal to max y, then what do I want to do? I want to say grid xy is water. Add me back to the frontier and append the below and continue. Otherwise, if not below in grid, so that means we're off the bottom. Now I want to say grid xy that equals, let's call it O. Let me do y. So that should be fine. Otherwise, there's something below me. So below me equals grid below. If below me equals O, which is off the grid, then I don't want to spill out to the right, and instead what I want to do is I want to say grid xy also equals off the grid. And I want to continue. And then otherwise I want to do this. So let's see if that fixes it or not. It's going to turn a bunch of things into O's. Max y is not defined because it's not max y, it's y high. Below in grid. And I have lots of problems here. And so now it's not working. Water flows, water flows, water flows, water flows, water flows. And then it's not doing anything. So what did I get wrong? Y equals W, frontier append that, frontier append below, continue. Otherwise, if not below in grid, otherwise there's something below me equals off the grid. Otherwise, while frontier print frontier. So so 501, 502, 501, 502, 503, 504, 505, 506, 499, 6. Because I'm not setting them, if not left in grid, frontier append left, and grid left equals W. Not right in grid right equals W. So let's see if that fixes it. Okay, so that's pretty good. Below me equals grid below. So let me try that. Would you look at that? But it's still not, it's not right. So, and it's not right because basically, if to the left or the right is O, we should also treat that as an O. Okay, so so if grid dot get left so now let's think about this. So so when I go here, I go down, I come back, I go left and I go left, and then I come back again, and so I need to turn myself to an O as well. Shit. So I feel like I'm close, but I'm also not that close. So like when it's at this stage, it's pretty good, and now he goes off, and now he comes back, and this comes back, and this comes back, and this comes back, and now 503 eighths. So I've come back here, and now so I basically want to turn these to O's as well. So so what I need to do is when I push this on, I need to keep him and then add those two, and then keep him, add those two, and then when I come back, I need to look left and right, and if those are O's, turn them into O's as well. So let me otherwise there's something below me. Okay. Okay, there's something below me and it's not off the grid. So I need to explore left and right, maybe. So let me do this. If grid dot get left equals O, so then grid xy equals O, or grid dot get right equals O. So if either guy next to me is an O, I'm going to make me an O. And then I am going to continue because I must have been on the way back. Otherwise, and so if left in grid and right in grid, so those guys are both there, then I also want to continue. And then otherwise, could go left or right or both. So I need to put myself back on the frontier. XY, put myself back on the frontier, and then do this thing. Okay, so now let's see if that works. And it doesn't work because I did not use a double equal. Name O is not defined, so that's okay. Okay, so now grid, and def count water grid goes to int return len of v for v in grid dot values if v in w or o. Flow grid count water of grid, and that's 57. And total number of tiles your water can reach is 57. So that is right. Okay. Tell me, this is day 17 input. Let's see. Been working on this for a while, so and it's kind of a mess of code, to be honest. I'm not thrilled with it, but we'll try it and see if it works. So with open data day17.text as f, this is a hard problem. Raw equals f.read, and now let's say grid equals make grid raw, and then I don't want to print the frontier anymore, so I'm going to remove that. But and I'm going to remove that break. But actually, I'm going to show the grid because I think that's kind of interesting. And grid equals make grid raw, flow grid, and print count water of grid. So let's run this baby and see what happens. None type has no attribute groups. Okay. So why is that? Is that because there's a blank line at the end? This is something no. Lines equals raw dot split n lines minus 1. Okay, so let's try that. And let's shrink this baby down because he's pretty small. And why did it stop? Did I screw up when I removed that break? I don't think so. So let's go print frontier. Is that really this much? Oh, God. Ugh. Okay, why did it not even show the frontier? And again, print frontier. Okay, so the frontier is 501, so that works. XY. So grid min x for xy in grid dot keys. Max x is 602. Min, you can't read this, it's too small. And max y. Okay, so grid xy equals w. frontier.append xy, frontier.append below, continue. So this should print high. So it didn't make it in that case. So why not print x, y, $501, y bigger than y high, that's not true, and y less than y low, that's not true either. So print got here. Somewhere I've done something really stupid, but I don't know what it is. Print bad. So y is bigger than y high. So print x, y, print x low, x high, y low, y high. 6, 1, 17, 92. In the example above, counting both water at rest and other sand tiles, the water can hypothetically reach. I see. So maybe what I should do is say this is 500 y low instead of 501. And then I don't know why they would do that. That's just kind of a jerky thing to do. But all this printing is crazy, so I'm going to stop it and just see what it's done so far, because I think this printing is going to make it run too slow. So here I've got water coming down, water coming down, water coming down, water coming down, and it's just going to keep doing this basically. And I think that's okay. So let's, rather than printing the grid, let's just print XY. And now let's try running that. Okay, and it seems stuck in an infinite loop, which is not good. So print show grid. And let's find out where it got before it got stuck. And then we can see what it got stuck on. And so it's here, and I don't even know how to debug that kind of thing. So it's basically doing all these things, and then it'll have to come back and do other stuff. So this is gonna. So the question is 481.17. So grid 481.117 is W 481.118. So I better do it like this. Grid.get. Nope. So there's nothing below me. 41.117, 41.116. So let's go 41.117 and 80, 117 is a wall. For 82, 117 is a wall. And so for 81, so now, so what's happening is I'm going back and forth between these two. So let's figure that out. So below, if not below in grid and wide, less than high, set me to a water, append me, and append below. Otherwise, if not below in grid, there's something below me. And it's not off the grid, so I need to explore left and right maybe. So in particular, I need to set me to W, right? So grid XY equals W. And let me do that. And not do this. And let's just say flow grid assert that count water grid equals 57. So let me just run this. So that's right. So now let me uncomment these and see if that fixes it. That did fix it. So 45133. So let us try that and see if it works. And if it doesn't work, I don't really know what we're going to do, but that's not the right answer. Your answer is too high. So let's check it out. Print show grid. So what happens is it comes down here and it flows. It covers this. It flows off both sides. It goes over to here and it flows down. It goes over to here. It fills up in here and then it flows down that way too. It comes here and fills that up. That seems reasonable. It flows here and goes. This looks pretty good. It flows off both sides. This guy seems to be behaving correctly. This guy seems to be behaving correctly. Fills up him, and goes off both sides. Here he shouldn't go off that side, so that's fine. Flows down here and fills him up. This goes down here, flows him up, and goes over that side. This goes here and goes over that side. So this all looks right so far. And there's nothing that's over the side, over the side, over the side, down here, and so it goes off that way. This 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 goes off that way. I don't know how I'm gonna figure out what's wrong with this in a giant water flowing thing. There's nothing here that looks obviously wrong. So I wonder if there's something at the bottom. But no, that looks. How do we get these two drips like this? That's kind of interesting. That one comes off here, and that one comes off here. It's not, but every one of those I could see one side of the bucket is higher, which seems like it shouldn't flow. So like let me find you an example. Actually, maybe this one is doing the wrong thing. Okay, so here's a first of all, to answer your question, here's one where it's not flowing off both sides of the bucket because one side is higher, and it's going off only to the left and not to the right because there's a wall there. So that's right. But here's one where it's doing the wrong thing. So this is interesting. So let's think about this. It's filling up. It's filling. So it goes down here, fills up, 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 and then it goes here, and it goes to both sides, and then it gets stuck here, so it backtracks, and it comes all the way back here as well, and then it goes up, and then why does it go to the left here? Because you feel like it shouldn't, right? So I wish I knew how to find this. I'll never find it again. It's pretty close to the bottom, let's say. So I go down, I've got a 0. I come back, and now what I see is if I have a 0 below me, I should not check left and right. And so why did I do that? If there's something below me, if below me equals 0, then set me to 0 and continue. So I don't explore that. So let's think about what happened when I got here. Because it's possible I got here some other way first. So like let's. I wish I knew. Okay, well we can do a couple things here. What time is it? It's past my bedtime. All right. That's not good. So let's look at show. For let's say y row in enumerate rows. So we'll do that row plus that, right? So now we'll print the row number at the end. So we'll run this, and then we'll print show grid. And now let's go find out where it's gone wrong. And one place where it went wrong is in 1630, right? And so let's go up and see if we can find the 1630s. So now the easy thing to do is to say if y equals 1630, print xy. Print xy grid.get xy. Okay, so I get to 495, 1630, 495, 1630W, 474, 1630, 433, 1630, 414, 1630, 412, 1630. So these are going totally from right to left. And now let's find 1630. So how on earth would I have so few 1630s here? seems somewhat astonishing to me, because the 1629 is actually the interesting one, but still, like, I would have had to get all of these in here. So let me just think about this. The problem here is that, let me actually change this to 1628, because that will tell me in which order I am. So I'm getting the left, getting 1628. And there's also a 412, 414, 433, 474, 495. Okay, so I come here, and I do all that, and then I come back, and now I come here, and really I need to, like, O out this whole row. Because the problem is that this whole row is basically flowing to the C. So now, same over here, basically. Like when I have, so that it seems to be my problem. So, so how do I need to deal with that? I need to deal with that by saying something below me. If below me equals 0, okay, so what I want to do is frontier equals 500. No. What I want to do is I want to basically say if grid so basically I think if I just do frontier.append xy and frontier.append left, and then also frontier.append xy. So I'm going to add this guy back, right? But now all I'm going to do is when I come back through him on the way back, I'm going to say I have an O to both sides, so I'm done. So that might make the difference. No. So because it broke the it broke this. And how did it break this? It broke this by so I'm here, I stick me on, and I stick okay, so let me could go left or right or both, put myself back on the frontier, and I don't want to put myself in the frontier again. So do left and do right. So that worked, but I thought I had this idea, but so basically I get here and there's water below me, so I say I need to explore left and right. So stick those guys on the grid, or stick me on the grid, stick those guys on the grid, go to him and go to him, and then once he's stuck, he's going to come back and he should assign himself O again. So let's make sure there's something missing. So empty below me and on the grid. So call me W. And explore below me. Okay, and then continue. Otherwise, empty below me, but off the grid. So call me O. Otherwise, there's something below me. If it's off the grid, then I'm off the grid too. And continue. There's something below me. It's not off the grid, so I need to explore left and right maybe. There's something below me and it's not. So I'm W. And now I have a left and a right. So if there's an So let's go back to this thing here. So it comes down, and now here's a W. So I fill up here, I get an O, and I stick all these guys on there, and right. So I go out there, and I go out here, and what I need to do is if I'm the first in the row. So how do I know if I'm the first in the row? So let's see. Let's torture myself by saying how many people have finished it. 87. So most people haven't finished it yet. So let me try and figure this out. So if I'm an O, then I want to spread otherwise something below me. If below me equals O, then I'm off the grid too. So so what if I, instead of putting a W there, I put the same thing as me. Grid left equals grid XY. grid right equals grid xy, and that way when I go to the left, when I go to the right, I'll come back as O, and then when I go to the other side, now the challenge would be that's not going to fix it. So what I need to do is not just this. I need to say what I want to do is, so if there's an O to, xy, if grid.getLeft equals 0, or grid.right equals 0, then I need to do this, but also set everything to my left and right to O. So how do I want to do this? I want to say while grid dot get so let's say x2 equals x plus 1 while grid dot get x2y equals w grid x2y equals O and x2 plus equals 1, and then same to the left while grid dot get, and then again let's do x2 equals x minus 1, and while grid dot get x2y equals w, grid x2y equals O, and x2 minus equals 1. So once I do that, I'm just going to go out to both sides and set it to O. Now let me can't assign to function call. What does that mean? Grid. Oh, because I got these backwards. Okay, so let's look at grid now. Print show grid. And so again, I have the same problem that I introduced where I'm not going in both directions. So I stick that there, stick that there. And so what I need to do is xy empty below me and out of grid, other something below me, if below me equals O, then no, that doesn't do that either. If grids so let me comment this out and go back and run it again. Print show grid. So let me this is not going to print show grid. So it's still not, I'm still having the same problem that I had before, which is that I come here and now so what I really need to do is it's not really that below me has an O, it's that below me is adjacent to an O. So maybe that's the issue. Okay. Okay. Check that below me is, so that's fine. Also, if it's adjacent to O. So adjacent to O equals false. And let's say, again, x2 equals x, while grid.get x2 x plus 1, while grid.get x2 y in OW if grid x2y equals O adjacent to O equals true. And then x2 plus equals, and then I'll say break. And then this is going to x2 is x minus 1, x2 minus equals 1. If adjacent to O, then we'll do this. Okay, so let's built-in function or method is not subscriptable. So once again, I screwed this up. All right, pretty soon if I can't get this figured out, I'm going to call it a day. Insertion error. Print show grid. So this has basically the same problem as always when I try and make this change, which is as follows. Actually, no, let me go back to that. And so the error is here. So now I don't need to do this. What I need to do is that might work. Nope. Print show grid. Nope. Still the same issue. So print xy. And let me comment all this out and see if I can make this work. And I also want to print show grid and print. So let me run this. So then we can see what happens here. It's flowing over the side, and then this O comes back up, 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 comes, and then I get to this guy, and And what happens is he has an O in his row, but he still needs to explore. So that's the logic that's wrong. If adjacent to O, then I'm off the grid too. So let's, otherwise, I'm a W. And so let's try this again. And then I'm getting close to giving up. So now it works, but I'm sure I broke the other one now. It's the sort of thing where I can either break my unit test, or I can not, or I can break my actual example. Print, that's a different number, which is good, I guess. So now if I go up to 1627, this is where it was causing a problem before, and it's not causing a problem now. So let's, now I've lost that answer. So 37,649, that's definitely lower than last time. So let's try that one. That is the right answer. Wow. Okay, continue to part 2. For a very long time, the water spring will run dry. How much water will be retained? In the example above, water that won't eventually drain out is shown as all remaining water not at rest has drained. So it seems like for each of my waters, I will stay if when I go to, let me take a look. The water that won't run out is, so the water that won't run out is really water that just it has to be in a row that only has waters and walls and no O's, right? So len g for g c in grid dot items if c equals w 30,000. Okay, so so let's make sure that print show grid. So anytime I have a W, I want to find a W and then make sure that when I go off to either side, all I see is W's until I so let's see if I can make this work. Okay, def and what are we calling this? Retained grid goes to an int, And so what do I want to do? What I want to say is retained locus equals set. And while true, try except stop iteration, return retained locus. So this will be a set. Let's say loc equals next xy for xyc in grid.items if c equals w. So I'll try and find the next location with a w. Okay. And let's say accumulator equals loc, and let's say xy. Accumulator equals xy, and I'm going to try the same left-right trick. So and keep equals true. How do I do this? Keep equals true. And let's say x2 equals x plus 1, while grid.get x2y in, and it needs to be either water or the wall. So if grid x c equals grid x2y, if c is water, then accumulator dot append x2y, and x2 plus equals 1. Otherwise, it's a grid. If c equals w, accumulator append xy. Otherwise, it's a wall. So break out of this while loop. And now let's do the same thing. Actually, what I want to do is while grid.get x2 y, see if c equals w, L if c equals pound, break, else it's must be w, keep equals false, and then also break. And now let's do x2 equals x minus 1. Let's try this again. equals W, x2 minus equals 1, otherwise it's wall break, otherwise it's W cube equals false break. So now, if we want to keep these, then retained locks dot extend accumulator, and then either way for loc in accumulator, grid loc equals, I'll put a sign there for counted, and that should be fine. And then I have the except stop iteration. Okay, so let me comment this out, and then what did I call the function? Retained grid int set object has no attribute extend. Okay. If keep for loc in accumulator, retain locs dot add loc. So I would have thought it had extend, but 29, and then that says 29. Okay, so that seems right. So assert len of retained locs grid equals 29. Print len of retained locs of grid, which is this guy, and this guy. So name retained locs is not defined because it's retained, I think. So that's saying 3112. So let's try that and see if it works. That's the right answer. 1 gold star, rank 183. You've completed day 17. Thank you to the 5 of you who stuck with me throughout an hour and 43 minutes of this crap. I don't know why I put up with it, but I put up with it. So git add data, git add day 17, git commit m reservoir crap, git push. All right, that problem kind of sucked. It did suck. I feel sort of guilty that I spent so much time on it. But anyway, that's me at Joel Grus. That's my YouTube at YouTube. That's my Patreon at Patreon. And thanks for watching. I'm going to sleep. It's way past my bedtime. All right. It was dumb of me to stay up that late. See